So here the flame sensor. So your flame sensor will look like this. So just a minute, I will show you here. Okay, flame sensor. Okay, so this is your flame sensor. So it has here photo detector, okay, photodiode, so which will detect a heat element or a flame. Okay, so then we have the potentiometer, like your IR sensor will have. Okay, so we have the again comparator. So this is your comparator, so LM37. Okay, then it has 3 pins, so these are used for controlling. Okay, you have VCC and ground and D0 pin. So this is basically output pin. Okay, so it will detect any flame, any fire or any heat element surrounding of this diode. Okay, so then it will convert that radiation or heat element into the electric signal, and that signal is given to the your comparator circuit. So this will check the threshold value. So if the how you are going to set the threshold value, so using the potentiometer. Okay, using this potentiometer we can set the threshold value, like so if you want to detect a higher temperature or if you want to detect a lower temperature, so that should be a setting by this potentiometer. Okay, so based on the setting of the threshold value, so how we are going to set that? So using this comparator or op amp basically, so the IC is called as an op amp, operational amplifier. Okay, so we are in the op amp, you have the two terminals, right, inverting terminal and the non-inverting terminal. So we are giving the one input to the inverting terminal, so that will set a threshold value. Okay, so based on the threshold value, so it will going to detect heat. Okay, so based on the threshold value you can detect the heat. Okay, so that value should be measured through your digital IO pin. So this is the pin. Okay, so just here, so if it will so based on the manufacturer again, so some of the sensor will produce high signal when fire is detected. Okay, so some of the sensor will produce low signal when the fire is detected, so similar to your IR sensor. Okay, so IR sensor will provide low level value when the object is present. So here also, so based on the manufacturing, so we will get different kinds of values. Okay, so this is the simple working in the flame sensor. Okay, so just it will detect the radiation or heat radiation from the surrounding. Okay, so it will convert that signal into electric signal, so based on the heat element or heat radiation. Okay, so that signal is compared with your comparator, so that value is set by your potentiometer. Okay, so if the value is greater than the threshold value, so then it will gives the high signal. Okay, so if the value is less than threshold value, so then it will give the low level value. So okay, here just we'll interface this flame sensor into our Arduino microcontroller. So after that, so we'll read the status of the information, whether flame is detected or not. Okay, so now I'll show the interfacing diagram. So this is your flame sensor and this is your Arduino. Okay, let's take Arduino image. Okay, just connect so VCC to VCC. Okay, so it is. So VCC to 5 volt and ground to ground. So we have the ground terminal here also. Okay, you can also connect it to here. So the next on the 13 pin. Okay, so then connect D0 pin to a digital pin or unlock pin. Okay, so we can connect it to either digital pin or unlock pin. So here I will connect it to digital pin on Arduino. Okay, just I will connect it to 8 pin on Arduino. Okay, so 1 minute guys. So this is the interfacing diagram of flame sensor. Okay, so just we have to fire in front of this sensor, so it will detect and then it will give high signal to the particular pin. So okay, so that is our D0 pin, and you can measure that signal through the 8 pin or connected pin, so you can do the particular operation. So here just I will blink an LED. Okay, or so I will turn on the LED when the fire is detected and will turn off the LED when the fire is not detected. Okay, similar to the air sensor. Okay, so here just we are changing the hardwares, but in the programming part there will be the remains the same programming or same procedure. Okay, because of these all our devices are the hardware devices or input devices. So for the input devices always we are going to read the information. Okay, so that information in the form of two types, so like a digital format and the analog format. So if the digital format means, so we will get only two values, right, high or low. So that's why there is a not much difference in the programming part. Okay, so if you want to read the analog values, so then connect it to the analog pins, so then you can use analog read instead of digital read. So that is the difference. Okay, so now I will open Arduino Ide. Okay, so now I will ask you, okay, Shilpa, pin mode. Okay, then
IR sensor input output.
so which pin you are connected with? The 8 pin, right?
8.
See here, so we are connected 8 pin. Okay,
Yes,
so
sir.
make 8 pin as an input. Okay, then
8 point. Pin mode.
pin mode.
LED.
Okay, LED means if I are taken LED. Okay, LED comma output, right?
Yes, sir.
So then
Void local.
okay,
Int.
int. Okay, int.
State
State
equals digital read.
digital read.
8. Digital read of 8.
So digital read of 8. Okay,
8.
fine. Then if
State is equal to low.
so low. Okay, low.
Digital write.
Digital write. Yeah.
LED
comma
low.
low. Okay, here I'm making that low. Okay, fine.
Else digital write.
Digital write.
LED comma 1.
LED comma 1. Okay, fine.
Okay.
So here. Okay, thank you, Shilpa. And then Pooja.
Yes, sir.
The code is correct.
Yes, sir.
Code correct ಇದೆ ಅಲ್ವಾ?
Yes, sir, correctly.
Okay, fine. So then now see here. So I will compile this code. So there is an error. So then Nandini.
Yes, sir.
So ಏನು error ಇದೆ ಇದರಲ್ಲಿ?
Sir, LED comma output. 13 comma output. Sir, but LED is also correct, no, sir.
But you are getting a error here, na?
Sir, we can assign 13 comma output.
So you can also, so okay, this method is correct, but you have to miss one statement. What that statement?
Sir,
So you can see here. So read this message. What is this message?
LED was not declared in this code.
So means, so we are not declaring any LED here.
Yes, sir.
So how we are going to declare LED?
Sir, int LED we can give.
So here in the previous, so this is called as an defining macros. Macros, or you can say that constant. So before using any variable names, so just we have to declare the macros, or we have to define the constant before starting in the loop or setup. Okay. So how we are going to define? So there are two types. Okay. So you can use constant int. Okay. Just int LED is equal to 13. Okay. So this is the LED. Either so you can also use constant int, because this value cannot be changed. So constant int. So this is the second type. So either so you can go for as define. As define. So LED, and here we should not use any. Okay. So this is the defining the constant or macros. Okay. So now, so this code is perfect, so then you won't get any error here. You can see. So it's compiling. So now done compiling. Okay, so there is no error. Okay. So then, so we'll upload this code onto Arduino board. Okay. I will connect the hardware. So before that, if you want to try it on simulation, you can also do that. So Tinkercad. Circuit, and is a new circuit. Okay. Let us check out whether flame sensor is there or not here. Okay, let's type flame sensor. Okay, here we are not having any flame sensor. Okay, just type fire sensor. No. Okay, then go for the hardware connection. Okay. Just I will show you the hardware connection. Just a second. So this is your flame sensor. Okay, it has only some of the sensors will have 3 pins, and here we have 4 pins. So 4 pins means, so they were provided the separate pin for digital and separate pin for analog. That's the difference. Okay, so here we have VCC. The first pin is VCC, and the ground D0 pin and A0 pin. Okay, so if you want to measure analog quantity, so then connect A0 pin. Okay, if you are measuring only digital information, so then connect D0 pin. Okay, some of the sensors will come up with 3 pins. Okay, so based on the manufacturers. Just I will connect, so VCC to VCC. Okay, then the second pin is ground. Connect ground to ground, and third pin I will connect D0 pin. Okay, because we are connected this output pin to 8th pin on Arduino, so that's why I will connect this third line to D8. So this is the simple connection. Okay, so here this is the 8th pin, and these are the VCC and the ground pin. Okay. Now go for the code and upload this code to Arduino microcontroller. Let's see it will use result or not. Okay. Here, like IR sensor, here also we have two LEDs on the IC, okay, in your circuit or flame sensor. So this is the power LED, and we have the another LED for indication whether fire is detected or not. If the fire is detected, so then it will turn on the LED. If there is no fire in the around the surrounding, so then it will turn off the LED. Okay. And see here. So just a minute, I will find out the lighter. Okay. Just a minute. So now I will detect a flame, so then LED is turned on. If there is no flame, so then it is turned off. Okay, on and off. So like that, so your flame sensor will work. Okay. So you can also connect. So now for interactive application, so I will connect buzzer. Okay. So for indicating sound. So if there is a fire around that sensor or a circuit, so then I will turn on the buzzer, or either I will give the indication. So for that purpose we have to connect buzzer. So we already connected in the yesterday class, right, previous class. So just connect ground pin to ground, okay, and positive pin to any one pin on the Arduino board, Arduino pins. Okay, so just I will connect it to 7. Okay, so I have connected positive pin to 7 and negative to negative. So then update the code. Just we have to add one more device, right? So then I will ask for some more.
13 ಪಿನ್ ಇರೋ ಹತ್ರನೇ ಬಜರ್ ಕೊಟ್ರೆ ನಡೆಯುತ್ತಲ್ಲ.
ಬರುತ್ತೆ. ಸೊ ಹೇಳಿ ಏನೇನು ಅಪ್ಡೇಟ್ ಮಾಡ್ತೀರಾ ಇಲ್ಲಿ?
ಇದು ಕೋಡಲ್ಲ ಸರ್, ಲೈಕ್ ಅಲ್ಲೇ 13th ಪಿನ್ ಇಂದಾನೆ ಇನ್ನೊಂದು
ಪ್ಯಾರಲಲ್ ಕನೆಕ್ಷನ್
LED ಆನ್. ಹಾ ಸರ್, ಹಾ ಸರ್.
So don't do that connection. Okay, so if you want to use buzzer for the other purpose, okay, so in the main applications, so you have to control different hardwares for the different applications. So only one hardware is sufficient for doing multiple applications. So in that condition, so there will be a conflict agata. So that's why you have to take another pin.
Okay sir. Hash define.
Okay, hash define.
Buzzer.
Okay.
12.
So here I have connected to 7. So now I will take.
Okay sir.
7.
Then 7. Then pin mode.
Pin mode. Okay.
Buzzer. Output.
So then the loop section.
In if condition, in digital write LED, 1 ಕೆಳಗಡೆ.
So when we have to turn on the buzzer also. Okay. So
Buzzer, 1.
Buzzer, 1.
1.
So then in the else part, so we have to make it as low. Okay, fine. Thank
0.
you. So digital, right. So now instead of turning on the buzzer continuously, I will go for blinking the LED. Okay, so then that sounds is better. Okay, so just I will show you this answer. Okay, result. So just upload the code. So it is uploaded. Okay, now so then so you can see here. So but LED is turned on, but buzzer is not working. Okay, so wait a minute. Okay, so here we have the reverse condition. Okay, just I will change the condition. Okay, so by default it will use low signal. Okay, then take low signal, then upload the code. Okay, maybe in your kit we'll get the different kinds of flame sensor. Okay, that sensor will work on the based on low or high signal. Okay, first check it the working of that flame sensor, so then we can decide the higher low in the if statement. Okay. So now it's fine. So if there is no fire, okay, so then both LED and buzzers are off. Okay. So just I will okay. So instead of turn on the buzzer continuously, I will blink that LED. Okay. So we are going to do that. Okay. This is the upgrade code for blinking a buzzer for 5 times. So let's see whether it will use correct result or not. So just here. It is continuously turned on. Okay, not blinking.
Sir, after delay, we can give digital write low, sir. We should make the buzzer pin low.
So we have to make it as high and low. So that
Yes, sir.
purpose, so we have to use another statement called digital. Okay, here digital write LED comma low. If you want to blink both, so then you can use LED. Otherwise, if you want only a buzzer, so then go for buzzer. Okay. Here I will make both the device. Okay. Digital write and buzzer comma low. Again, we have to give the delay. So just I will give the delay for 200. But here also we will getting continuous on and off. Okay, so it's not finding out the only 5 times. Okay, just see the result here. Okay, so just I will upload the code again. So buzzer was not declared. Okay, here. Okay, done uploading. Okay, let's see. So you can see here. So you can see here it's continuously blinking. So it's not blinking for 5 times. So here we have to make another change. Okay. So add that change here. Is so just use after the for loop you have to use delay. Okay, just I will use delay, so then it will wait for some time. So okay, just I will take 2 seconds. Okay, so let's execute this code. So code done uploading. So then let's check the result. Okay, you can see here it's blinking only 5 times. If it is not detected, so it is turned off both device. If it is detected, okay, so this sounds better now. Okay, so like that, so we can create the different application using the flame sensor. Okay, so this is simple application. So then you can add on the other devices also, like you can add LCD display. So when the fire is detected, so then you can update this information on the LCD, and if it is not detected, so then we can go for normal operation. So normal other operation, or we can also display there is no fire. Okay, so that is also an interactive application then. Okay, so now I have to interface LCD. So what is the code?
Liquid crystal
Okay, just you have
LCD
to
ಮತ್ತೆ
write
pins
like this. Okay, just a liquid crystal, then
LCD ವೇರಿಯಬಲ್ ನೇಮ್ಸ್
okay,
ಆಮೇಲೆ
LCD.
ಆಮೇಲೆ ಪಿನ್ಸ್ ಯಾವ್ದು ಕನೆಕ್ಟ್ ಮಾಡಿವೋ ಅದು
So just I'll go for again 2, 3, 4, 5, 6, 7. Just assume that this is 7. Okay. So then I will change the buzzer to 9. Okay, 9. So this is LCD initialization. So then, so this is pin assignment. After that,
ಆಮೇಲೆ ಎಲ್ ಸಿ ಡಿ ಡಾಟ್ ಬಿಗಿನ್ ಏನೋ ಇದೆ ಸರ್. ಎಲ್ ಸಿ ಡಿ ಡಾಟ್ ಬಿಗಿನ್
we have to initialize the
16,2.
Okay, we have to initialize the LCD using LCD dot begin. Here we are using 16 cross 2.
16
Okay, so we have different variants. So you can also, if you are using 20 cross 4, so then use 20 comma 4. So either if you are using 32 comma 8, so then you can use 32 comma 8. Okay, like this. But here we are using 16 comma 2. So then after that,
ಎಲ್ ಸಿ ಡಿ ಡಾಟ್ ಕ್ಲಿಯರ್ ಲೂಪಲ್ಲಿ
so here where we, okay, here I will use the LCD dot clear, then
ಪ್ರಿಂಟ್
so print. So just go for here, this is the
Fire
loop for,
ಲೋ
so this is the loop for
ಫೈರ್ ಇಸ್
fire is detected or
Off.
not detected.
ಆನ್
So,
ಸರ್.
fire is on or fire is detected. I will say
Fire is detected.
Okay. Just okay, fire is detected. So fire is detected. So then you have the delay here, so it's fine. So in the loop, so we have to make it as an LCD dot clear. So clear. So in the similar way, LCD dot print fire is, okay, fire is, I will take another line because the characters are more than 16. LCD dot set cursor, so 0 comma 1. Okay, so then go for LCD dot print not detected. Okay, so just using Muzi. Okay, so after that, just here I will use delay, okay, for avoiding the flickering of the LCD. Okay, so then I will upload here. I am not connecting any LCD here, so just I want to connect. Okay, so I already shown the LCD connection. Okay, 1 minute. Just I will connect the LCD. Just a second guys, I'm connecting LCD display. Okay, this connection is already shown in the previous class. Okay, sensor. Okay, so here we will find out many applications using flame sensors. Okay. So now we will discuss about the serial communications, and here I will discuss basically UART communication. So before going to the serial communication, you guys have any doubt about this this program? Okay, if you have any doubts, you can ask me now. Let's start with the serial communication. Okay, or we say that UART communication. Okay. So just I will remove the connection. Okay. So let's talk about the serial communication.